Hi everyone, this is the video example for Mastering Physics problem 35.32. And the problem reads, a 15 centimeter focal length converging lens is 20 centimeters to the right of a 4 centimeter focal length converging lens. A 3.4 centimeter tall object is distance L to the left of the first lens. So here's a picture of what that's going to look like. We've got lens 1 and lens 2 separated by 20 centimeters. Our object is some distance L to the left of lens 1. The focal length for lens 1 is 4 centimeters. Focal length for lens 2 is 15 centimeters. And we can use a ruler to kind of trace out what this is going to look like. Our object from lens 1 is going to create a real image somewhere in between lens 1 and 2, and that's going to be the object for lens 2. And because it's in between the focal point of lens 2 and the lens, we're going to get a virtual image to the left of lens 2. And you can see it kind of just marked out what the distances are going to be. And if this drawing is confusing or picture is confusing, I wouldn't worry too much about it, because you don't really need it to solve this. So the question is, for what value of L is the final image of this two-lens system halfway between the two lenses? So what do we know? Well, we have the thin lens equation. 1 over the distance to the lens plus 1 over the distance to the image equals 1 over the focal length of the lens. And we know that the focal length is going to be positive because it's converging lenses. And we know that the distance to our image is going to be positive if it's a real image. Basically, if it's going to be to the right of the lens, and it's going to be negative for virtual images if it's going to be to the left of the lens. So if we kind of just make like a table of the different values we know, S1 is L, that's what we're going to solve for. We don't know what the S prime of lens 1 is. The focal length of lens 1 is 4 centimeters. S2, we don't really know what that is either, but we know that it's going to be 20 meters minus the S prime of 1, because the object for lens 2 is the image created by lens 1. And S2, S prime 2, is going to be negative 10 centimeters. We know it's negative because it's a virtual image. It's to the left of lens 2. And the focal length of lens 2 is 15 centimeters. So if we write out the thin lens equation for the second lens, we can solve for S1 prime. So because S2 is 20 centimeters minus S1 prime, you can plug that into the equation and then set it up to solve for S1 prime. And then we plug in our values for F2 and S prime 2, and we come up with 14 centimeters. And now we know what S prime 1 is, so we can use our thin lens equation for the first lens, set it up to solve for S1, because S1 is L. So L equals 1 over the focal length of 1, which is 4 centimeters, minus 1 over s prime 1, which we calculated as 14 centimeters. And we get 5.6 centimeters. And that's the answer for the first part, part A. Part B, what is the height of the final image? Okay, what do we know? We know that magnification equals the negative of the distance to the image over the distance to the object. And we know that the ratio of the heights for the image over the height of the object is the absolute value of the magnification. So to find the height of the image, we just got to multiply the absolute value of the magnification times the height of the object. And then it's also important to keep in mind that if the magnification ends up being positive, it's an upright image, and if magnification is negative, it's going to be an inverted image. So here are all the things that we know, all the things we can input from what we calculated in part A. So we know we were given the height at 3.4 centimeters. The height of the image is what we're solving for. So that's just going to be the height times the total magnification, which is the magnification for the first lens, times the magnification from the second lens. These values were from part A, and M1 and M2 are the equations that we just talked about. And so to calculate the height of the image, we're taking the height times the total magnification, the absolute value of the total magnification, which when we input the values from part A, we get 14 centimeters. And then the final part, what is the orientation of the final image? Well, like what we talked about before, we need to know the sign of the total magnification. So the magnification of the first lens times the second lens, it's going to be negative because you got a negative value and a positive value, which is a negative. So the final image is inverted. And finally, for an assessment, for my assessment, I just drew out the picture where each square on this grid paper I made 1 centimeter, and then I used a ruler, and this final image is 14 squares tall if you actually measure it out. So that was my assessment.